Hi everyone, my name is Cassandra Russell. I'm the Acting Vegetable Crop Specialist with the Ontario Ministry of Agriculture, Food and Rural Affairs. And this lecture today will provide an overview of disorders observed in field-grown tomatoes and peppers, and is part of our 2020 IPM Scout Training Workshop series. I just wanted to acknowledge that most of the photos I'll be showing today are from OMAFRA's Crop IPM website, which I'll link to in a second, as well as photos from Amanda Tracy, Vegetable Crop Specialist with OMAFRA. If you're not familiar with Crop IPM, this website is a great tool for scouts and covers a multitude of different topics related to fruit and veg pests, scouting calendars, as well as soil diagnostics. We also have a blog, which is onvegetables.com, with a number of great resources that we post updates to regularly. You can subscribe to our blog in order to receive notifications on new posts pertinent to your crops directly sent to your email. As mentioned, this lecture is going to focus on disorders of field tomatoes and peppers. So first off, let's start by discussing what is a disorder. Disorders are plant abnormalities caused by abiotic or environmental factors, such as extreme temperature or weather events, and physiological issues related to nutrient availability, to name a few. These can affect the plant at any stage, and although they may not be incredibly damaging on their own, a lot of disorders allow the plant to become susceptible to further damage by other plant pests. Today I'll be covering a number of disorders common in both field tomatoes and peppers here in Ontario, and I hope that by the end of the lecture, you as a scout will feel confident in recognizing and identifying these types of disorders in a field setting. The first group of disorders I'm going to cover today are related to weather conditions. First, we have frost damage, and this can occur in both tomatoes and peppers where temperatures are in tomatoes below -1 or -2 degrees Celsius, and in peppers when temperatures are at or below 0 degrees Celsius. This is something that is seen on the whole plant soon after transplanting, and with severe temperatures, symptoms will be seen across the entire field. But if the temperatures were just reaching those thresholds, it may only affect some plants. With both tomato and peppers, frozen leaves and fruit surfaces initially have a water-soaked appearance. So we can see in the top photo, we have a tomato plant that's just undergone some frost damage. And then later, those plants will likely turn brown, sometimes even black, as seen as in the bottom two photos of tomato transplants. Chilling damage is very similar, although it happens with air temperatures that are below 10 degrees Celsius or soil temperatures below 15 degrees Celsius. Once again, it can infect and destroy whole plants, and most often you'll see the damage across an entire field. So the next is sandblasting or wind damage, and this occurs with high winds, usually on exposed light or sandy soils. It may cause stem and leaves on the windward side to develop a light tanned, rough colored areas that you can see in the top left photo of some pepper transplants. If severe, it can stunt or kill plants entirely, significantly reducing yield. Also, the whipping of young plants by strong wind, as seen in the top right photo of a young tomato plant, can also severely damage or even kill plants. So wind and cool temperatures can also cause the desiccation of plant tissues. So it's important to know that wind strips, sometimes cover crops and windbreaks, will help minimize these problems due to wind and sand movement. Hail injury can affect both tomato and pepper crops. Light hail injury may cause ragged holes in the top foliage, possibly even cause depressed areas of various fruits or various sizes and shapes on exposed fruit, seen in the top photo by on some exposed green peppers. So those spots on those fruits are lighter in color than the surrounding tissue. In more severe hail cases, injury results in shredded and sometimes defoliated leaves and can also cause severe abrasions on the stem, as seen in the bottom right photo. If hail is able to break the skin of the tomato or pepper fruit, the surface of the spot becomes grayish-white and often paper-like. A few days after the injury, a spot may be surrounded by a greenish tan halo. Sometimes when scouting a field, you may come across a sudden appearance of a circular area of damaged plants, and this is due to lightning. The circular patch of plants can be anywhere from 3 to 20 meters in diameter, with plants on the outer edge often showing less damage than those on the interior. Leaves at the ends of branches will begin to droop, followed by wilting and sometimes death of the plant. You may also see that one side of the stem may be caved in, or the inside of the stem may be completely hollow or have a ladder-like structure arrangement of tissue. That's seen or demonstrated quite well in the top left photo. You can see there the hollow stem with the ladder-like arrangement of tissues. So the next group of disorders I'm going to cover relates to recognizing disorders in fruits and leaves. So first we have leaf roll, which tends to occur in tomatoes, especially when experiencing hot, dry growing conditions or when soils will become waterlogged. Injury to the roots may also trigger a leaf curl response. Some tomato cultivars are especially predisposed to leaf roll, and the leaf roll itself is thought to be a moisture conservation measure for the plant and doesn't often negatively affect productivity. So what you will observe is quite straightforward. The edges of the leaves will roll up and inward, and the leaf may also develop a leathery texture. Blossom drop is also commonly observed in both tomato and peppers and is caused by a variety of stressors. In tomatoes, blossom drop may be caused by stressful conditions such as temperatures above 32 degrees Celsius during the day or above 21 degrees Celsius at night, or if temperatures drop below 20 degrees Celsius during the day or drop below 10 degrees Celsius at night. Peppers, on the other hand, they are also sensitive to flower or fruit drop, with temperatures reaching above 32 degrees Celsius or below 15 degrees Celsius during the day, or at nighttime temperatures if they rise above 21 degrees Celsius. Other contributors to both peppers and tomatoes blossom drop may include high relative humidity, high fruit load, windy conditions, improper nutrition, drought, disease, sometimes insect damage. What you will see in the field is flower stems and the calyx turning yellow. Blossoms or small fruit may stay on the plant for a period of time, as seen in the top picture, yellow and dried out tomato blossoms before aborting. In the bottom photo, we have a small pepper fruit that has aborted. It's important to remember that both tomato and pepper plants may naturally lose blossoms or small fruits, especially when carrying a heavy fruit load. And blossom drop is not generally of economic concern, especially because some varieties are more or less susceptible to blossom drop. Next, we have blossom end rot, and initially thought this was triggered by a localized calcium deficiency in the blossom end of the fruit. It often occurs both in tomatoes and peppers with dry soil conditions, reducing the amount of water movement into the plant, which ultimately interrupts the movement of calcium to the fruit itself. So therefore, blossom end rot is caused primarily by dry soil conditions, not a deficiency of calcium in the soil or plant specifically. But there are a number of other factors that may influence the development of blossom end rot, which I won't go into detail about. With peppers, blossom end rot is associated with fluctuation in the plant's water supply and also heavy fruit load, and it can be more severe under high nitrogen rates and fast growth conditions. So the symptoms you will observe are small water-soaked or light brown areas of the fruit, usually on the blossom side, when the fruit is green or ripening. The lesion will then darken and can enlarge rapidly, becoming sunken and black in tomatoes or straw-colored and papery in peppers. It may affect over half the fruit, and the damaged tissue allows for the colonization of other pests to invade the fruit. It's also really important to note that blossom end rot lesions, they may look similar to Sunscald lesions, so it's really important to note the location on the fruit, whether or not that lesion has had exposure to excessive sunlight to be able to tell the difference. Here's just some photos of some atypical blossom end rot damage. On the left, we have some internal blossom end rot symptoms, as well as on the right, we have sidewall blossom end rot, and these are specific to a certain variety of tomatoes. As mentioned earlier, we also have Sunscald. It's also seen in both tomatoes and peppers and can be caused by fruit suddenly exposed to sun, usually due to shifting foliage cover from either winds or harvesting, as well as early in the season, tender young leaves and stem tissue can be especially susceptible to injury from intense heat and sunlight. So the symptoms of sun scald can affect leaves, stems, and fruit. On fruits, you will primarily see yellow areas where the fruit has been exposed to the sun. And exposure to intense sunlight can also cause tomato fruits to heat up to the point at which red color won't be able to develop at all. In both tomatoes and peppers, areas tend to be sunken and light brown to white colored. And then this also allows the fruit to be then invaded by secondary organisms, causing rot. So we have some photos of some peppers in the top two photos, and then the other photos of tomatoes are some varying degrees of damage. And in the right, bottom right side, we can see that's a more extreme case of some sun scald that has already been colonized by another pathogen. So the next group of disorders I'm going to cover are color disorders. With a lot of the color disorders, different tomato and pepper varieties vary in their susceptibility. So it's important to understand the fruit variety that you're scouting, because that will be beneficial on understanding what you should be looking for. Yellow shoulder, also sometimes referred to as green shoulder, yellow eye, is a common disorder in some tomato varieties. This disorder is initiated just shortly after fruit set and well before the ripening of the fruits. So when the fruits do start to ripen, those areas will not develop their color, even if harvest is delayed. And soil potassium and magnesium levels are thought to be involved in the onset of this disorder. So the symptoms, as mentioned, the tops of the fruits do not ripen properly. The flesh of the fruit shoulders remains green or turns yellow. So you get the tops of the fruit not looking like they fully ripened. Yellow eye is used specifically to describe a disorder when only a ring of tissue around the stem is affected. And we also have internal white tissue, as shown in the bottom right photo. So although the exterior of the tomato may appear red, fruit with this disorder exhibits areas of hard white tissue on the shoulders and or entering the core. And this is believed to be one variation of the yellow shoulder disorder. Next, for tomatoes, we have blotchy ripening, also sometimes called gray wall. This is linked to a boron or potassium deficiency, also excessive nitrogen, high humidity, temperature fluctuations, and moisture levels, as well as soil compaction can factor into the development of this disorder. Similar symptoms can be caused by some viral infections, so it's important to note what your pests your crop is susceptible to. The tomato fruit will appear mottled green, yellow, and red, and the flesh develops large patches of hard gray to yellowish tissues that do not fully ripen. When the fruit is cut open, as seen in the bottom two photos, brown strands of vascular tissue might be seen. Sometimes symptoms related to blotchy ripening may also be called gray wall, and these seem to be more common in high tunnel tomatoes as opposed to field grown varieties. Next, for color disorders of peppers, we have stiff or color spotting. So the exact cause of this is unknown, but it is usually associated with cool temperatures. Low calcium or excessive nitrogen and potassium may also be involved. And with this physiological disorder, results in small 1/4 to an inch diameter or less dark spots on the skin of the pepper fruit, or sometimes just under the wall of the fruit there. Next, we have silvering, which is caused by a separation of the outer epidermal cells of the pepper fruit. This is strongly linked to the variety of the plant, but there also may be environmental conditions playing a role, as the severity of this disorder can vary from year to year. you'll see this silvering appearance on bell peppers, and the severity of the silvering can range from just a small dime-sized area on the fruit to covering more than half the fruit in some cases. Lastly, we have purple striping in peppers. This is usually associated with cool temperatures, but once again is only seen in certain varieties, which vary in their susceptibility. Indicative of the name, you'll see patches of purple stripes that in some cases can cover the entire fruit. It's important to note that this has no direct impact on the yield or taste of the peppers, but is usually avoided as distributors want consistent peppers that are uniform in color. So next, we're going to cover some abnormal fruit development in both tomato and pepper fruits. These disorders are both related to environmental conditions during flower development or pollination. First, we have catfacing in tomatoes. So this occurs in large fruited fresh market tomatoes that are most susceptible, and also there's a wide variation in susceptibility among varieties. So the causes are related to temperatures below 15 degrees Celsius during flower development, normal hormonal herbicide injury, high soil nitrogen levels, excessive pruning may also contribute to this problem. Catface fruits show scars and opening at the bottom end and are often deformed. So in the top left photo, we have a range of catfacing symptoms from mild to moderate, and the two other photos show some more severe deformities that are in larger varieties. And it usually affects the earliest fruit of large fruited varieties. This is just some more photos of catfacing. As mentioned, there's high variety in the susceptibility, especially when it comes to larger fruits, such as heirlooms that are a lot more susceptible to these catfacing disorders. Next, we have zippering in tomatoes, and it's a physiological disorder that is associated with pollination problems and can be attributed to low or high temperatures or high humidity during pollination. Zippering is the appearance of a thin brown linear scar that extends from the stem end of the fruit, either all or part way to the blossom end. And sometimes opening in the fruit wall may occur along the scar, which can be seen in the bottom right photo of a tomato there. Next, for tomatoes, we have puffiness. This is associated with temperatures above 35 degrees Celsius or below 13 degrees Celsius, and is attributed to poor pollination, as well as improper nutrition and extreme variations in soil moisture, as well as genetic factors that can play a part in this development. So the puffiness disorder describes fruit that have developed flat sides rather than rounded, as seen in the top photo there. When cut open, the cavities are enlarged and may lack gel, and the fruits are usually quite light in weight. For peppers, there is abnormal fruit development observed in different environmental conditions. So in cool conditions, being 15 degrees Celsius during the day or 5 degrees Celsius at night during flowering, this might result in abnormally flattened seedless peppers, which may also have a little pointed area at the bottom, which can be seen in the top photo on the right-hand side. On the other side of things, we have exposure to high temperatures, so 32 degrees Celsius during the day or 21 degrees Celsius at night and higher for several days while flower buds are forming. This will cause blocky fruit development with extra segments, which can be seen in the bottom three photos. And these adverse conditions during pollination may also result in other fruit deformities, such as openings in the fruit walls. Lastly, we have fruit cracking. So this may be caused by alterations in growth rate, fluctuations in moisture or temperature, even fruit exposure to full sun. The cracks can appear from the mature green to ripe stage of maturity, and cracking generally appears near the stem scar and is a result of rapid fruit growth, usually brought on by periods of drought followed by heavy rains or irrigation events. The concentric cracking can often occur when standing water sits on the shoulders of the fruit as well. So we have russeting or rain check, also sometimes called weather check or shoulder check in tomato. And those photos at the bottom right are demonstrating this cracking disorder that some varieties are especially susceptible to and triggered by rain. So these in the bottom two photos are tiny cracks or russeting on the upper shoulders of the fruit that will be seen. An affected area will not fully ripen, which ultimately significantly reduces tomato shelf life. Next, we're just going to cover a few chemical-induced disorders. So first, starting off with walnut wilt, which is an interesting one. It will occur if if crops are planted within 12 to 15 meters of walnut trees or in soil from which walnut trees have been removed in recent years. So it's due to the uptake of this chemical juglone from the tree roots, which is incredibly toxic to tomatoes along with a variety of other plants such as peppers. The symptoms closely resemble those of fusarium wilt, including the yellowing and browning of leaves, leaf drop, and stunted growth. So in addition, stems will turn brown or streak, and peppers or tomatoes growing next to a walnut tree will abruptly wilt and die. To determine if the wilt is due to the presence of a walnut tree or another pathogen, make sure you're scouting the area for signs of walnut trees. But even if you don't find those trees, soils may still have the toxic chemicals from decomposing roots from being removed several years ago. So next we have fertilizer burn. When salt levels are too high around the roots, salt injury or fertilizer burn can occur. And high rates of fertilizer contacting the foliage can also cause burn, and especially is more severe in dry soils since it's lacking the moisture to dilute those salts. Early in the season, browning roots are seen, is indicated in the top right photo, the two seedlings on the right showing that brown root. Leaf scorch is also a common symptom. So foliar effects will occur on the leaf margins, tips, and cause wilting and stunt the growth of the plant. We also have air pollution injuries, and tomatoes are particularly sensitive to air pollution, also byproducts of combustion. Tomato plants are especially sensitive to ethylene and will show symptoms within 24 hours. And those symptoms include either twisting or wilting of the foliage. And these conditions are usually made more severe during when barometric pressure is high, as these conditions can cause air inversions. So coming to the end of this lecture here, we obviously don't have time to go into depth on the characteristic damage from various herbicides used in or around tomato and pepper crops. But we do have some photos to help diagnose these issues up on our crop IPM website. Same goes for more general nutrient deficiencies you may encounter and the resources we have available on the crop IPM website on using soil diagnostics to help detect those issues. So I know I've already mentioned crop IPM a number of times, as well as our ON Vegetables blog, but here are some other additional resources that can be incredibly helpful to diagnose not only disorders, but also insect and disease pests you may encounter while scouting. And with that, I'd just like to say thank you again for tuning into this lecture on disorders of field tomatoes and peppers. My name once again is Cassandra Russell, Vegetable Crop Specialist with AMAFRA, and I'd like to acknowledge Amanda Tracy for providing a number of the photos and slide materials, and I wish you all happy scouting.